Hey, Ranni here, and what a delightful day it is. Shall we make a game? Well, sort of not really, because we know now that we're not actually going to be making a game, as we reached like the 50% mark and went, oops, this isn't going fast enough. We are instead making a game engine. And I kind of mentioned this about a week ago when I said that, well, when I went the reason I'm kind of having difficulty kind of like focusing stuff, I know that continuing to build the game is pointless, it's not going to get built in time. Someone will take the engine, turn it into its own thing. So the plan going forwards is whenever I have kind of like free time during the week, I'm going to work on the game engine. I'm going to do on the weekends, I'm going to stream a bit there and then, try and focus on the content creations, the 3D models, textures, whatever, and then go back to 5 days a week game streaming. Hell yeah. So what are we going to do today with this? We're given this is our final stream. Am I even in the right project? Yes, I am. That would be embarrassing, wouldn't it? So I've been looking at is starting to build out kind of like the scene graph, because this was actually the bit that was hardest to get right, and the bit that I didn't actually really get right in the previous version of the engine. So I'm going to. So I've started like filling these out. There's no actual code backing these yet. They're just the headers, but I'm trying to figure out exactly how I want kind of everything to fit into this engine. So I guess we can fire up the engine, because I actually went behind the scenes and I think I might have fixed the issue with the sound kind of pacing. Okay, there we go. Let's do a build. Oops, I'm hosting 2 web servers rather than building one. Did that kick the other one off? No, it didn't. Oh, that's interesting. Oh yeah, it picked another port number. Okay, that's fine. Yeah, it's open the web browser, and if I launch the game right now, you should see nothing. But fear not, this is actually intentional. This is what we expect. So I should, if we go into the video handler over here, in the event handler's video handler, I can then include from buffers video h. I can then set the video color, the first color to, let's include our header for colors. Do I have all the nice constants in here for like, all the various colors? No, I don't. Let's define some of those. Try to remember how you actually how you do like an inline constant for an array. I think it might be something like this. If you even can. I don't think you can. Yeah, because one of the differences between this engine and the previous version of it is I've tried to make the colors an array, because like you don't really use them as I previously had them as like a number and then sliced out the various bytes in it to actually make colors. I wasn't really tend to use it like that. Let's see if we can do that though. Can we do that? Is that allowed? Yeah. So the answer to what I'm doing today is I'm just picking up a random part of the engine and working on it, I suppose. Okay, color red mode. Oh yeah, let's call it red. Def to namespacing. Okay, yeah, it's not going to allow me to do that. Maybe I go back to my previous approach of having them as kind of like just an integer and slicing bits out. Yeah, I might do that. Just have a quick look. Is there a nice way of... No, it's not going to be used like it's an array type. Maybe we have these as constants instead, but if they were constants, we wouldn't be able to use them in like arrays and structs and things on the global scope. So, oh wait, we don't cast it. We do that, right? That'll probably work. Will that work? Expression must be a modifiable L value. What is this? Do I have to do that? There we go, it's happy with that. Just keep throwing syntax at it, it'll be happy eventually. Incompatible pointer to integer conversion assigned to byte. It's because this is an array type, it won't let me do that. Maybe there was something to that approach of using numbers, huh? Or maybe I should just... Yeah, I'm actually kind of curious to see what this actually did on disk. I'm curious to know, sorry, in memory. I'm curious to know whether it's actually... I'm hoping that hasn't made like a jagged array of pointers. That'd be kind of nasty. Let's just make sure this works at all. That will probably produce a red pixel in the corner. Let's have a look. I don't see a red pixel. Okay, now we've got a problem to investigate, haven't we? Let's intentionally throw an error and make sure it's actually doing something. I think I called it raise. Oh, I called it throw, didn't I? Yeah. I called a function throw because I'm looking to I'm looking to mess up the any potential parsers as much as possible. Okay, that definitely works. We're definitely hitting this. Yeah, we're definitely hitting this code. Let's put it back in. Oh, there's a red pixel. I guess it just didn't pick up the change. Okay. Okay, that's working nicely. So the question is this way? Sorry, is this way of making a color the best way to do it? I don't think it is because I don't really want to be doing all that. But how often are we going to be using constant colors? I think the answer is not very. Yeah, it's not going to be very common, is it? But it is a fixed size thing. I'm going to go nick the color header out of my old engine. As much as certain bits of it gave me the heebie-jeebies, I think this is genuinely a better solution. Let's have a look in here. Right, yeah, we had this as unsigned, so I'm trying to avoid unsigned types in this because I'm not a huge fan of them. We can... That might mean I can get rid of the byte header, which I was never quite sure on. Let's comment that so we can make sort of make a note of ourselves that it could be removed. Colors, number of channels in the color. Let's steal that. That's good. And we can then steal these implementations. One of the things I really need to think about is color interpolation, something I don't really have an answer for at the minute. Oh, actually, this entire naming scheme is better. Actually, I'll just take this version. And that means I can also bring across all of these. I'm just going to steal this entire header. It was actually quite well designed. And then we just make sure that our naming is nice and consistent across the board. Okay, so I go to the video buffer file. There it is. Yeah. And let's remove all of these. Let's remove all of our prefixing, all our namespacing. Hey, that should be nice. Oops, what am I doing? Where's the bit where we define opaque? There they are. We need to put that further up because we're going to be using them to make colors down there. Let's see, create an opaque color. This just theoretically mean that we have some conditional logic running on this, but it's a constant. The compiler should have no trouble getting rid of that. And then we can get rid of all these prefixes. All these prefixes need to go. They're just annoying. There's never going to be a collision because we control the whole code base. There's no libraries here. Man, this part is pretty bad looking. So I'm not quite sure about this division by 255 because if you do like a division by 256 or another power of 2, you're able to use the bit shifter to very quickly, to very quickly sort of do the division, but you can't do that with like other constants that aren't power 2, I don't think. There's a lot going on here, isn't there? Okay, all right, there's a lot going on here. Do our best to clean it up. And I'm going to rename alpha to opacity because alpha doesn't really mean a lot and opacity is very explicit about what it's used for. Oh, this is terrible. I need to sort this out. What I might actually do is actually turn this into a function because how often do you actually need to do this kind of thing statically? I mean, these statically, yeah, all the time. But these, not so much. Okay, let's send this on. Where's that all mention of alpha? Opacity is not pre-multiplied. I'm pretty sure I said, yeah, 32 bits per pixel. Now, I should probably state what the order is here because they from least to most significant byte. There we go. Now, I'm not sure whether this being signed is going to work because like I don't usually signed and unsigned logic kind of like just sort of even out nicely. I don't know whether they're actually going to work out here. You have to test a few colors and see what happens. Yeah, let's see what happens. Let's go to our video event handler and we should now be able to go video color 0. It's going to be red and it should work. Okay, that seemed to work. Maybe I should have done something, a bit more, a bit more I can tell whether it's working or not. Let's make a pretty little rainbow, just so we can see that all the channels and stuff are combining nicely. I think I've got magenta in there, yeah. And let's also try layering a color on top of another. So we're going to clamp color. So we've got is it source and destination? Yeah, source and destination. So the source is the color we're going to be laying on top. So let's layer a 50% opacity red on top of let's go for blue. That should oh, I didn't like that. Oh, I didn't actually finish renaming everything. Oops. This might be the bit where we need to switch over to an unsigned value, which wouldn't be the end of the world. Be a bit annoying, but wouldn't be the end of the world. Yeah, shifting a negative signed value is undefined. Yeah, that's our issue there. So it needs to be unsigned. That's not the end of the world. Yeah, we're not going to be doing any real math with, well, I mean, other than this math, we're not going to be doing a lot of math for this type. So let's go to the definition of this and let's just use one of these. Yeah, I'm trying to avoid all system headers here. And then I've got some simple like assertion helpers and things, which means that we can be pretty confident that our types are working correctly if they come out the right size. Oh, I've got too many levels there. Oops. Okay, we're doing good, we're doing good, we're doing good. It's still not happy about something. Why do you think it's signed? Why do you think it's a signed value? I am confused. Why do shifting a negative signed value is undefined? Why do you think it's signed? Oh, I know why. I know why. Okay, right. The reason it thinks it's signed is that we're feeding integers in, right? And we're not actually telling it what the type is anywhere. It's just going, well, it must be me. It must be a signed integer because that's the default in virtually any kind of, well, not even a modern programming language, any programming language in general. Oh, we have a little rainbow. How nice. Let me just adjust the video settings so we can zoom in and see it a bit more clearly. Hey, that's working nicely. Right, what else we're going to do? We're going to test some of the other features. So this should have mixed a. That's our magenta. This should have mixed a red with a blue at 50%, and that looks like a less intense magenta. So that looks like it's worked. If we put it in at 255, it should be completely red. So basically, like we're layering like a 100% opacity red over a blue. Yep, that works. Okay, that seems to work really nicely. So if I read through this and make sure I haven't left any clangers in here. Yep, that looks good. Happy with that. Okay, replace color header. And let's go to that byte file. Let's get rid of it. I'm not convinced it was ever really needed. Let's find all references to it. And if I ever need it, I can always just pull it out of the I can always just pull it out of the Git history. Remove bytes header. It'd be nice if I could auto-generate this, to be honest. Probably is a way, I just haven't found it yet. Doxygen is a massive, massive thing to try and learn. Okay, so next up. We start moving some of the other headers across. So I guess the next step would be to draw a line. So if I just bring up the old code here, I'm just going to grab the line drawing code. There's a few things I want to change about this. It's a good opportunity to sort this out. Let's go to the video folder and let's put our line.c in here. Right, yeah, this is, first of all, we're going to get rid of all these prefixes. Get out of here. Nobody wants prefixes. And that's those gone. And I'm also going to get rid of the destination. So previously you were able to specify an image, whereas now there's only one frame buffer for the whole game, which should be enough, generally speaking. I can't think of a reason it ever would be, and I'm ready to eat those words a bit later. It just means one fewer argument to pass around, you know? And I'm thinking, rather than... what if we passed in the 3D coordinates instead? That could be quite nice. So I want to do depth in here. That's one of the things this line helper didn't previously do, was depth. I found it was actually going to be quite useful. Oh, those can be replaced as well. Get rid of all these prefixes. Look how much shorter this code's getting just by removing all these damn prefixes. And yep, get rid of all these. No prefixes, no thank you, get out of here. I'm going to roll back the change I made to the video settings. There we go. And this is going to be where we're going to start building camera components. Not long after this. Okay, let's keep going through. I might get onto those today, might not. Just keep removing prefixes. Get out of here. Yeah, I'm going to see if I can come up with some good structure for kind of like, doing color interpolation, because it seems like something that's getting pretty common. It's going to get really common when it comes to rasterizing triangles. Because I plan on adding vertex color to the current triangle rasterizer, which is going to be a big difference. It's going to allow us to do some really nice looking environments without a lot of textures, and it'll give us that really kind of, that very particular look PlayStation 1 games tend to have. Okay, that's good. That'll do. Next up, we're going to actually fill out the camera component, I think. Going to camera components. Yeah, so we've got all these to define. So let's just grab this, copy paste, turn it into a C file. I did turn the video settings back. Yes, I did. And just delete all this. So one of the changes I've actually made here is that previously we had like an absolutely monstrous stack of arguments to virtually any component. For example, if you wanted like a subcomponent, you had to like say, well, it's this entity, but it's this component within it. And no, just instead going to have two separate constructors because they do technically different things. The other thing is I'm going to start having it as defaults for things, because generally speaking, there are same defaults for things. Like say all these camera options, I'm going to make them so they default to the same thing as Blender does by default, because that's usually what you want. And additionally, cameras have audio levels. Well, default them to, 1, 100%, because if you want anything else, that's the exception to the rule. Okay, so do I have in here, I have my index header. Do I have? No, I don't. I'm just going to steal something else from the previous project. I have these two helpers that are super, super useful for finding empty slots. And we're going to put the error header, so it's going to be in. Let's have a look at this. Could I actually turn this into a proper function? Not really, because yeah, it's this vacancy structure, and the idea is that you basically give it an array, and you're basically telling it to find an empty slot by looking for a specific value in there, and it's not really an equivalent to that. There's not, yeah, there's no way to do like generics in this language. But I guess, no, because in some cases I'm going to be doing like, sneaky things like using pointers, basically reusing memory to, rather than like having like an explicit kind of like, does it exist or not field. In some cases I'm going to have things more complicated than that. Okay, yep, good. Yep, that was good. Okay, so we're going to use this. It's basically just a, oh, hang on. That one's not called empty index. It's called vacate it. Yeah, we're basically just going to use this to find an empty slot into which to put a camera. Because much like before, we have no memory allocated. We're basically just pulling them out of a kind of a queue type thing. Yeah, so I guess we start off by, in both cases, we actually need to go in the shared code path pretty much to set up a new camera, and then there's going to be a final step that actually attaches it to a component. So, yeah, we're going to pull out an index and yeah, let's have one here for allocate camera component. That seems good. And it's going to do this thing in here where it kind of finds an empty index and a vacancies array. Do we have one? We don't really have one yet. Oh, I've just realized something else that's just really, really obviously missing from this. I don't really have a way to say which area of the screen the camera should take up. That's kind of vital, isn't it? It should default to covering the entire screen. Filling the viewports. Now here's the question, because I have the ability to have safe areas, right? Which might not actually fill the screen. Well, so they actually want this like a proportional screen filling area. You know, I'm going to go like, well, this you think about it, right? What you're going to use it for is largely like split screen stuff like that. You're not really going to use it for much else. So all they really need to be able to do is like give like say proportions of the screen to take up, like maybe in clip space or something. Yeah, so let's add some new things down here. Camera component. Yeah, lefts, I guess I call it. That'll do, I suppose. I don't really like that as a name, but that'll do, I suppose. Okay. Locations of the cameras, of the camera components, viewports, left edges in clip space. Minus one is left edge of the video buffer 1 equals right edge of the video buffer. Okay, that should do. Right, what do I have to do here to make the spell checker happy? Spelling suggestions, what you got for me? You know viewport is a word, but you don't know that viewports is a word. Well, I'm going to ignore that spell check suggestion because I know better. And rather than being the left edge, it's going to be the bottom edge and the top edge. Easy. Now when it comes to interpolation, because I'm going to have render level interpolation, there needs to be a way to actually because it's going to be like an internal copy of the previous value for these. How's that going to work? Because what I don't want it to do is like start with like every viewport filling the screen, and then like over the course of a frame, like a tick kind of like shrinking to the correct part of the screen. That'd be kind of odd. There might also be cases where you legitimately want them to kind of transition and move around. Okay. We're going to need that next and previous. Oh, we're also going to need that for like the camera settings. Maybe we have just like a function you can call to let's see what to do for this, just so we're not like wasting tons of time deliberating over a feature we're not even really going to be using. To do a way to cancel animation interpolation. So find me an empty index, and wait, I should actually declare this extra thing, shouldn't I? They're not extern, we're declaring them here. And I'm just going to declare them all in the big stack here. Very nice. Now at the moment we don't actually have anywhere that lists whether a camera component exists, so we're just going to have to add one. And I guess we'll use one as occupied. It's not great, but what else can you really... Oh, wait. There's something obvious we can do here. We can take a pointer to their matrices, yes. What do we call them in the entity file? We call them transforms, but we actually want the inverse. We want both. I think we're going to want both. We're going to want this one for actually transforming the scene for you to look at, and this one for transforming it to sort of like interact with. So yeah, and we're going to inverse transforms. Now, I don't think we're ever going to have to modify them from this end, so I want to make them constant if possible. I'm still going to have to look this up every time I go to like create a pointer with some degree of constantness. I have to look this up. So I pointed to a child, it's that one. Well, you can't change the value, but you can change where it points. So yeah, that's the one we want. We want const before the primitive type, well, array type. Okay, so find me an empty index, and we're looking in the transforms, and we're looking for null and number of camera components. And we're going to have the first and last occupied. And we need to define an error number. Do we actually have error numbers anywhere in this engine? Yeah, we do. We have them here. Nice. Okay, indicates that no entities available. What's the term I used in the actual header here? No entities left to allocate. Okay, that'll do. What's that called again? Yeah. Oop, does not exit does not exist. There we go. Okay. Actually, wait. I think they should be negative because I think I had like a conventional trying to set up where engine level errors are negative. Because that way the game can use positive values. Yeah, that'll do. And this thing we're currently writing here, we're actually going to need something just like this in the don't go blank. In the entity and component side of things. So we're going to want the miscellaneous header, which is, that's where we're going to get null from. And then we're going to want exports, buffers, error. Yeah, there it is. It's going to be error, no camera components to allocate, and I guess we just call it index. No, we can't do that as a type called index. I'll just call it camera, why not? And does this need a following quote, semicolon? No, it doesn't. Okay. And then we're going to do our pre-initialization. Let's have a look at what we put in the document up here. Okay, so sensor sizes is going to be, camera is going to be 36 millimeters. Oops, you didn't have to do that, Visual Studio Code. Camera, near clip distances, 0.1 and then 1000. It's actually quite a good range. And then our focal length is going to be 50 millimeters. Incidentally, I have no idea how these actually combine, really. I just wrote a brute force solver. Collected some test data from Blender and ran a brute force solver to try and figure out, given the test data, what it's actually doing. And I don't understand the math that came out the other end of my brute force solver. And then we're going to want to cover the entire buffer. And then we should be good to return a camera. Oops, I'm doing it twice. And then we basically call into this. Right, that'll give us our, so we've now got a an index into this, into these arrays that we can use. We now need to make a component and link the two together. So I think I've got component. Yeah, it's just called component. And have we brought in the right header for that? No. Oh yeah, we have. And what do we pass that? We pass it the entity ID, well, index. Pass it in meta, which is going to be the camera. So, we have an index back into our array. So whenever we're interacting with this component, we know which camera it is. And we're going to need a destroy callback. So Yeah, it looks like this. There we go. Nice and simple. Let's rename it. Let's just allocate. Why not? Destroy. And it's going to have a component handle, which is just going to call it component. Now, a component handle is something a bit weird I've come up with, and I might change this, but I'm not sure yet. It's basically an integer where some of the bits are an index into this array, and some of them are an index into this array. Not sure yet whether I'm going to stick with that or not. So we can go extract. Sorry, what's it called? It's component handle index. Like meta. There it is, yeah. Got it. And we're just going to null out that transform so that it knows that we are done with it. Oh yeah, there's one more thing we have to do in here. We actually have to go look up the transform of this entity and put it in there. So let's make it so we pass an entity index into there. And we're going to want to grab our entities out from the parent list. Probably already imported it for at least one of these headers, but we can then from that get the transform of the entity transform. Like that. And we can do the same for the inverse transform. This is refusing to acknowledge these exist. I wonder what I've done wrong there. I've probably done something wrong. Okay, that should be good. And then at some point we're going to have to have a function here that gets called from our kind of like our video callback so we can advance state, and also one in our tick callback so that when we're doing interpolation we can make a record of the fact that we've advanced a state. Yeah, just took a moment. Destroy. And we've then got subcomponent, which is very, very similar, except you give it a component. Now I think I have a thing in component to get the entity number out of it. Do I not have that? Huh, actually, thinking about it, I could put the entity ID inside the component handle as well. That'd be kind of useful to have. Yeah, that really would be handy. So let's get a limit and let's put remark in here saying that remark, the structure component structure of a component handle may need to be adjusted if this is set to extreme values. That'd be so useful to be able to just go like, which entity is this for? Oh, it's that one. Oh, fantastic. In fact, we can do it with all of these. So let's try and figure out how we actually want to divvy up these components, the bits of this, because we have, it's assigned integer, so we only have 31 to work with. But let's go here, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, these are our bits. And let's just space these in a bit. So most of the time we're going to be dealing with the, yeah, I think like 99 times out of 100, we're going to be dealing with the index. So I want to give as much as possible to that. Well, I want to have them near 0, so it's just a matter of masking them off. Yeah, dead easy to get to in all cases. So how many bits are we going to go for that? Now, I don't think you're likely to have more than 255 of any one particular thing. Actually, what if I just went for like an even split of like 10, 10, 10? How many? That's like 1024, right? Probably gonna have more components and entities than that. So yeah, let's make the first 8 bits. Sorry, that's 9 bits. Maybe 512, actually it's a good round number. And then we can have how many rows here? Let's just put space after all of these. 1, 2, 3, 1, 2, 3, 1, 2, 3 components, and then we can go 1, 2, 3, 1, 2, 3, 1, 2, 3 entity. Right, so I'm thinking we're probably going to have way more components than entities or any particular thing. So I'm going to give 2 extra bits to components. Oops. And then I'm going to give 1 extra bit to entities. Let's just work this out here. So we've ended up with 9 bits of metas. So metas 9 bits equals that's 500. We can have up to 512 of any particular component type, and then that's 10, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Component 11 bits is going to be 2048. So we have 2048 components in the scene. That might be lowball, but I'm not quite sure yet. 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be 10. So yeah, you can have up to 1024 entities. Now for the kind of scale of game that we're making here, that's actually going to be fine. That's not even going to be... I'd be surprised if we even hit 128 entities in most scenes. So I'm happy with that. But something else I'm actually going to do is I'm actually going to swap these around. And the reason I'm going to do that is that to get to the meta, all we need to do is mask. To get to the component, all we need to do is bit shift. And to get to the entity, we need to do both. And the entity is going to be the one we use the least often. There is an additional complexity when it comes to deleting components and entities because there's an element of hierarchy to them. Wait, hang on, have I done this right? I haven't like double counted one or something. I just want to 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are we short of a bit here? Hang on a second. So it'd be bits 0 to 31, but we're cutting one off. So it's 0 to 30. So yeah, I've got a spare bit. I've missed one somehow. Damn it. So I'm going to put that in the meta down there, just so we can get a nice even spread. That's, yeah, close to even, but with just that 1 extra bit spent on that. Hang on a second, I'm just checking my math again. I'm just doubting myself here. This is basic addition, dude. What is happening? What is happening? Okay, that's good. That's actually right. Okay, I've confirmed now. That's right. So that's 10. That's 1024. Right. Composed of 3 fields of bits. Index to the component itself and the global pool. Okay. So which is specific to the bits from least to most significant. Okay, an index which is specific to the component type itself. component meta. Okay, and then index of the, and then we're going to want the entity of the index of the component's parent entity in the whirlpool. Okay, and then we do still need like a separate array of parent components, but that's not a big deal. Oh, actually, could I have a bit in there specifying? I could have a bit in there specifying whether it's a child of an entity or a component. That would be neat. A bit specifying whether 4 fields of bits, whether the component is the child of parent component entity or component in the global pool. Okay. Right, okay. Let's just go back to our little diagram here. I'm going to steal a bit from the meta and say parent type. Okay, so what do we have here? We have meta max is going to be 0 to 8, so that's, yeah, that's up to 1023. That's good. And then to get the, let's swap these around so they're a bit more even. Extract the index specific to a type of component from handle to it. Okay, yep, that's good. And yep, that is literally just at. Okay, it determines whether a component's handle is for the child of an entity. True when the component handle is the child, direct child, let's be more specific, a direct child of an entity. And that's going to be checking that 1024 bit. Yep, that's good. And a component. Oh, that was nice. And then we can just do that. And then we have one more to do, which is to get the, actually no, I've got a few more to do. We need to get the component index out. So that's going to be basically shifting it down, how many there? So that's, well, it's going to be 20, isn't it? Easy enough. And that's the parent index of from a component handle. Mark, use, and I'm going to refer to these just so that it's obvious, you know, what this even represents. Nice, that's good. And, oh, I should probably also have like a component handle none. Component handle. And I'm thinking that's just going to be -1 because you're never going to have that realistically with these bit fields. I'm basically using the, I'm basically keeping clear of the sign bit. And let's see what I called a index none. How do they describe that in the? There we go. A value which can be used in place of a component handle to represent nothing. Okay, that's good. And then here, we're shifting it down to 10. And then we can shift and, you know, sort of like mask these off in any order we want to. But in this case, I'm going to shift it first and then mask. And that mask shouldn't be there. And then what do we have? We have, well, we've got component, which is 11 bits. So it's going to be up to 2047. That should be enough components, I think. Well, that's an hour, isn't it? Lots of engine dev. I'm going to be continuing to work on this. Maybe not so much this week, just because there's a lot going on in the background. But I'll definitely be doing more dev on this on stream at the weekend, Saturday, Sunday. But tomorrow something spooky is going to be happening. Something ominous and difficult to remember. Have a great evening, and I'll see you then.